Good afternoon, everyone. My name is Szymon Trocha. I work for Poznan Supercomputing and Networking Center, which operates the NRN in Poland. But I also work in the Jan project, where we develop and support perfSONAR, which is a measurement architecture that can be useful for users, for researchers, and operators. Next slide, please. So looking at today's global research and education networks, as you can see in an example picture, which in fact shows the interconnections of the Jan network that spans not only Europe, but also other continents, in fact, the whole world. Such a network ecosystem, which includes the NRNs, but also commercial operators, consists of multiple networks, and all of them interconnect, but at the same time, they are owned and operated by different organizations. We usually, in our environment, call them domains, and they are operated not only by different organizations, but they also are built in a different way. They have different architectures. They use different interface speeds. They have different policies configured. So we have this complex situation, and all of these heterogeneous set of networks must operate seamlessly from one end to the other. That means when two researchers or two users wants to transmit data from one end to the other, this has to work very well. And today, most of the collaborations between the users in the research world, but also in the normal life, is distributed globally. So we have the situations where usually the traffic is transmitted over multiple domains and traverses multiple networks. But the issue arises when there's a problem in the network, especially when the performance is lower than expected. So then we have to have tools or architecture in order to easily troubleshoot the networks in such a complex environment. And what I'm going to talk to you today is perfSONAR, which goal is to provide such network measurements between the organizations involved. Next slide, please. So what perfSONAR is? perfSONAR stands for Performance Service-Oriented Network Monitoring Architecture. First of all, it's a collaboration of institutions who gather together to build that architecture and implementation, but it's also a set of tools and their architecture to set the network performance expectation. That means to be able to give a kind of answers to the users, to researchers, but as well as to network operators, what they can really get from the network. Are they able to successfully transfer the data they want to send from source to destination? What speed they can achieve? How the application will work, which finally should make an optimal use of the networks for that application used by the researchers or the user. We also tend to say that it helps to fix the network problems, but especially looking at those problems which we call soft failures. It's quite clear to see when the network is down, if your interface is down or a cable is cut. It's usually immediately noticed by the network operations centers and the network engineers, but it's much harder to see the so-called soft failures. So when the performance is degraded, but there is no obvious reason for that, and it's much more difficult to observe such kind of issues in a multi-domain environment. So the users just see that the performance is degraded and the application doesn't run well. And perfSONAR helps to fix these problems in a way that, because it's distributed globally, it's an architecture of different instances of perfSONAR. It speeds the time to troubleshoot because you are able to see the performance of the network and run the measurements over multiple domains. Because these problems are usually much harder to diagnose when multiple networks are involved. You need to contact the domains, you need to arrange test sessions, etc. But the perfSONAR architecture allows you to speed this process. It's not just about making the measurements, it's also about publishing the data, because if you already have the data, it's good to store them, to be able to analyze, also to be able to properly visualize so that it's useful for the users and for the operators. I think it's important to say that it's part of the model which some of you may know. It's called Science DMZ, which is a kind of architecture to build nodes in the networks or parts of the network, which is especially equipped, designed, configured in a way to better support efficient data transfers. It's especially useful for the research environment, but may also be applied to any other networking environment. And this data, I mean the tests, the measurements, or the data collected, can be used by any types of users, both researchers and the network operators. Next slide, please. When you first encounter perfSONAR, you will probably look at something we call Toolkit, which is the single instance of perfSONAR, which you can easily install. It comes in different flavors. You can use the CentOS ISO as a single point of installation, but you can also use bundles of Debian or RPMs for the Linux distributions. I mentioned that perfSONAR is a collaboration, and indeed it's an open source development, its implementation and packaging of all the infrastructure and protocols, which is developed by a partnership of a few institutions or organizations. They come from different parts of the world. We have partners from ESNet, Indiana University, Internet2 or University of Michigan. There's also a partner from South America, the Brazilian NRN. And from our, let's say, European side, we have the JANT community, which works under the umbrella of GN4 EU-funded project. With the toolkit, with perfSONAR, you have a capability of making the network measurements, and there are many metrics we are covering. Let's take an example of at least key of them. So like throughput, so how much you can get out of the network. That's about setting the expectations I mentioned before. Then we have, of course, latency, so how much it takes to get from the source to destination. Metrics like packet loss, duplication, or reordering. So do we really, are we really sure that all our packets from my application make to the other side? We can also run trace routes to check the path the traffic is traversing, and many more. It just depends from the tool, from the measurement tool, which is embedded in the toolkit. It's usually quite easy and straightforward to configure and install a single instance, and you can immediately have it running and available for testing. Next slide, please. But it's not, as you can imagine, about a single instance, because if I'm speaking about the multi-domain environment, it's not just about a single organization which hosts a single perfSONAR instance, but it's about multiple instances. And we have a concept of meshes. So when you deploy a mesh in an organization or in the network domain, it is trying to coordinate several nodes in a structured way so that you can run the measurements between them. In fact, these nodes can potentially be maintained in different networks, so it doesn't have to be just your own nodes, but you can also easily run the measurements towards the other nodes located somewhere in the world, and you can easily visualize those data too. Of course, provided that these remote nodes, which are not maintained or owned by you, are allowing you to perform such tests. And in order to build a mesh, all of the nodes under your responsibility share a single mesh configuration so that they know how to make the test, how often, where to store the data with all the parameters necessary to run the network measurements. Next slide, please. When you already have this infrastructure in place, it's important to run regular testing. Of course, you can run a single test with perfSONAR tools, but it's rather much more useful to be able to observe the trends, to be able to get the historical data, to see how the performance changes over time, so that when an issue arises, you can easily compare the current status to the previous one. And it's better to just not to wait for the users to report problems and then fix them, but rather be alerted and react on them. So the architecture allows you to not only collect the data with the network measurements run by the instances, but also to archive them with several types of archivings, and also to nicely visualize in a kind of grid. You have an example here where you have different hosts in your mesh and a grid of test results. And finally, you can be alerted when something goes wrong and the threshold is crossed, which means that the performance threshold is below or higher than expected and set by the network operator or researcher. And in order to do that, the architecture and the implementation includes tools to describe and configure the topology of tasks. When I say the topology of tasks, that means that we need to describe all the measurements, we need to define the parameters, the tools which are used, and how all these instances talk together in order to make the measurements. We have a way to define and publish this configuration as soon as it is done. So all the mesh details are consumed by the hosts participating in the mesh, and all the individual host knows what to measure and how, and finally where to store the data. And then you can have an instance of visualization tool in order to present such nice grids to your researchers, to your users, or to the people who administer the network. Next slide, please. This picture shows you the architecture of perfSONAR, and you can see that it's not monolithic, it's rather a few building blocks. That also means that this is an extensible architecture, and you can easily extend that when you are interested in adding some new components or some new functionality. So let's have a look at the bottom of the picture where you have tools. You can probably recognize some of them. These are the actual applications that run measurements over the network. So you have iPerf, traceroute, ping, or other ways of doing continuous measurements. There are multiple of them. You can specify any of it to run the measurements. And what's important, you can add easily new ones. We have a mechanism called plugins, so you can easily extend that if you are interested in a specific measurement, which is, for instance, dedicated for your own purposes, for your own application. Above that, there is a component called pscheduler, which is an important piece of the architecture used for scheduling. So making sure the tests do not overlap, making sure the parameters are set correctly, also making sure that the policies set by you or the limits set by you are fulfilled. So that, for instance, you may want not to allow some networks to run the measurements towards your node. And finally, when the data is gathered from the tool, then it's sent for archiving. We are supporting a few ways of archiving. The most common one is so far something what we call ISMOND. This is a time series database where all the data is stored. But in fact, although this is dedicated tool for these types of measurements, we are also looking recently for new ways of storing the data, more related to things like Elasticsearch and be able then to visualize data with Kibana, Grafana tools, etc. Next to it, you can see this orange box, which is used to configure the meshes I mentioned before. So something to support all this complex configuration. And finally, above, there's this visualization layer where you have all the tools used to visualize different components, graphs, the Toolkit user interface, so this user interface for a single instance. Then we have something what we call Medesh, which is a tool to visualize the meshes, and something, of course, to support the configuration of PSConfig. And finally, there is this green box of the architecture, which we call lookup service. You may wonder how to find the perfSONAR nodes, and this is in fact the component which helps you to discover. So all the hosts has a capability of registration to the lookup service, so their existence can be known to the whole world. And this lookup service data can be used to find the instances all over the world, and they can also be used in order to support the automatic configuration of the meshes. Next slide, please. I mentioned that an important part of perfSONAR is this plugin architecture, which is a way of ensuring extensibility to the whole implementation and development, because we work as an open source community with multiple partners. We are free for any community involvement in system extensions. So if any partner or a researcher or an organization has any specific interest in providing some additional functionality, it's welcome to do that. And in order to do this, we have a concept of so-called plugins into this main component of pscheduler. And it allows the integration of new types of plugins. We have at least 4 of them mentioned here. So we have test plugins. Tests are the way how the measurements are described. So it's a kind of abstraction so that the tools know how to measure, with what parameters, etc. Tools plugin is this crucial part at the bottom of the architecture. So the actual applications to do the measurements, like the iPerf tool or the tracepath tool. And when there is a new one, then it can easily be added as this type of plugin. Another type of plugin is Archiver. I mentioned that we have this Szymon time series database, but we also developed some other types of plugins when the users wanted to store the data in some other places or in a different way. So for instance, we have syslog. When the data then is sent in the JSON blob to syslog, we have an HTTP interface so that the data is available through this type of interface. And based on one of the requests and cooperation with the research community, we also have a RabbitMQ archiver, which sends all the data to this type of interface. So you can see that this is really extensible, and you can define multiple ways of storing your data. And finally, there's the 4th type of plugin, which we call context. This is about creating the measurement environment. So before a measurement is done, pscheduler can define and establish the context. For instance, an example is the Linux namespaces, where you can possibly use different routing or different virtual interfaces in order to run your specific measurement when you want to use different environment. Even to make the development process easier for the community and for the developers who want to extend the architecture, we provide something what we call plugin development toolkit, PDK, which supports the integration of the third-party tools with pscheduler. It has an API, the REST API, it uses JSON, but the plugin development toolkit really reduces the time and effort to create new plugins because it automates the building of the environment and it speeds the development time. Next slide, please. I said that it's important when you have instances scattered all over the world. And here you can see a picture coming from the lookup service registration service. We currently have about 2,000 advertised instances in the world. When I say advertised, I mean those that registered to the lookup service. Of course, if you do not register your instance to the lookup service, you are free to do so. There are private instances which are there in the world, and then they are not visible here. They are deployed in multiple places, in NRNs, in research organizations and institutions, but also in virtual organizations. So you can imagine that there is an organization which is spread over multiple domains, like, for instance, the LHC community, which is an example of such organization. And yeah, as I said, many of them is available for open testing, and you are free to do a test towards such an instance, and you can also include such instance into your mesh in order to make regular testing and observe the performance of the network. Next slide, please. Before I finish, I would like to give you a nice example of how perfSONAR can be used in a real environment in order to troubleshoot the network performance issues. And here is the part which was provided to me by our colleagues from JISC. So your local environment, let's say. And the two main actors here were the Queen's University in Belfast. And on the other side of the world, let's say, there was an Institute of Astronomy in the University of Hawaii, so located far away. And it's for sure the traffic between the two institutions is traversing multiple domains. So you have at least this Queen's University Belfast, you have Janet network in UK, then you have JAND as a pan-European network, Internet 2 as the US network, and finally somewhere regional or local in the University of Hawaii. So if any issue arises in this place between the two institutions, then it's really a problem and probably a time-consuming debugging process to find where the really problem is. And there are astronomers there. They use a telescope which is located in Hawaii in one of the islands. There is a telescope on top of the mountain. What they do is they are trying to detect the near-Earth objects, so protecting the Earth from falling something down from the air, from the sky. It involves large data transfers from different measurements, observations, and experiments, because there is a set of collaborating organizations around the telescopes, and they are used to analyze the data. They are used to do visual video processing of the data in order to find this object. So usually there is a data transfer, so large data transfer between the actors. Next slide, please. And it happened in October. Then the usual transfers, they typically run at something about 5 megabytes per second from Hawaii to Belfast, and that was fine. And they observed that approximately 1 in 8 of these transfers were running very slowly. So there was something impacted the data transfer down to about 50 to 100 kilobytes per second. And that was really impacting the experiments, and the transfer started to become backlogged. So it was abnormal comparing to the situation, to the day-to-day situation. Because the institutions involved in these experiments are using perfSONAR instances and perfSONAR architecture, the idea was to use the tools. So they started to looking at the traceroute outputs to find the path the data goes through, and then looking also at packet losses, because the packet loss may impact the performance of the application. They were testing over multiple paths. You saw these multiple domains, so trying to narrow down where the performance is impacted, or which is the piece of the networks which can be pinpointed as the source of the problem. They noticed that on the packet loss plots, there was a steady increase of packet loss at some point in time, which may have proved that there is really an impact on the network performance because of the TCP traffic behavior. Next slide, please. So finally, what was concluded here, also proved by the throughput graphs, which you can see below, they found an example of so-called soft fault. So when something is not evidently, obviously broken, like a link down, but rather foiling silently because of the error rate on one of the interfaces in the aggregated link between London and Birmingham. So there was one of the 8 of these links, which has a very low error rate, not initially seen by the network operation center, but enough to affect the TCP transfers and the application. So you obviously know that if there is a even small packet loss on such a long distance, it can really impact the TCP transfers. And the additional problem was that this was the hashed link on the aggregated links. So it wasn't just always impacting the transfer, but one of 8. So finally, they knew that it's on this link, and the interim solution was to take the faulty link out of the aggregate. And again, the throughput and all the measurements were correct. Next slide, please. So just a few words about the future. We'll look into new ways of data integration. So I mentioned that we will try to look at about storing data into things like Elasticsearch. Elasticsearch is related. We went for OpenSearch, which is a good solution because of the licensing. And we are sure that this will help the community to find other ways of visualizing the data retrieved by the measurement. We are looking into the analysis of the data because there's a lot of data gathered by the architecture. So we want to find ways to do it better and in a more efficient way. And also looking at future releases in terms of the operating support change, due to the CentOS OS release strategy happened last time. So we are looking for alternatives for that, probably things like Alma or Rocky Linux, and of course, maintaining the current support for CentOS 7 and Debian. Next slide, please. So I will conclude here with pointers to some of the resources. You can go into that and see the documentation, but also some movies from the perfSONAR project, and also the resources coming from the Jant project related to the services we provide based on perfSONAR and the results of the measurements. That's it for me for today. So thank you very much. Next slide, please. If you need some more information, you can drop me an email or ask any questions. Thank you very much.
Do we have any questions from the internet? if anybody fancies to come down and ask a question, please feel free. Yeah. We'll give the internet a moment.
I see somebody mentioning, I guess it's Tim on the chat, that there is a 10 gig personal node in Janet network. So feel free to go there. You can even see the Toolkit interface, and you can run the measurements towards it.
Okay, it doesn't look like there's any questions, but hang on. Okay, doesn't look like there's any questions, so thanks, Szymon.
Thank you very much.